when we get to that 300 megapascals, it really lightens the color some. We get a nice reddish color, but we're not getting the cooked color.
Yeah.
And so it makes that dark cutting steak, which people don't like, has discounts that are associated with it, makes it look like it almost a normal steak.
Welcome to MeatsPad. In collaboration with the American Meat Science Association, it's a platform dedicated to share breakthrough knowledge that is accessible to the global meat industry. On each episode, you'll have the opportunity to listen and learn from meat specialists and professionals about the whole meat industry. This podcast is brought to you by the U.S. Meat Export Federation, Ultrasource, equipment and supplies for the meat and food industry, Viscofan collagen casings, the best alternative to animal gut casings for a better taste and sustainable sausage making.
Hello, meat folks. Welcome back to the MeatsPad podcast. It's your happy, hungry host, Phil Bass. And now we have two guests with us, folks who have been collaborating on a bit of research. We have Dr. Gary Sullivan with University of Nebraska-Lincoln, and we have Dr. Ram, and I'm not going to go for your whole name, man. It's up to others to check you out, but from Oklahoma State University. Great example of bringing different minds together, different institutions together to work for a common goal. So thanks, guys, for joining us.
Thank you.
Yeah, and Dr. Ram, you've been on the podcast before,
yes,
right? Gary, this is your first time,
This is my
isn't it?
first time.
Okay. We're here in the studio, our portable studio at Oklahoma City at the Reciprocal Meat Conference 2024. Of course, we have our executive producer Jimena in the background over here. We've been talking about some of the cool things that you guys have been working on. First off, Dr. Ram, whenever you're on, we're talking about color, right? Meat color. And we'll get to that. But there's some really cool technology out there that I've been exposed to probably about in the last decade or so. And I've known it as it's HPP. I've known it as high pressure pasteurization. But Dr. Sullivan, tell me a little bit about how that can be modified to more of like a high pressure processing. Is that what you called it? Yeah.
I oftentimes refer to it as high pressure processing, but the basic concept of high pressure processing is you take products that are packaged, you put them in a vessel, fill it with water, and you pressurize it to most commonly used to control pathogens. So a lot of ready-to-eat meat products, they'll use it to reduce microbial load as a post-lethality packaging pasteurization process. And so oftentimes we'll use like 600 megapascals for 3 minutes as a way to do it. Put that in context, 87,000 PSI.
Wow.
And so it's a great way to look at pasteurizing products and reduce microbial loads. And so there's a lot of work done in cooked products. We've set proteins, it works well, but there's a lot of interest in trying to figure out how we could do it in beef because, we think of raw beef, we have that bright cherry red color. Well, when you go through and use high pressure processing as a way to pasteurize it, you're getting a reduction in color. It gets lighter, it looks slightly cooked, and no one wants to buy ground beef or a steak that looks slightly cooked. And so one of my former colleagues at University of Nebraska, George Cavender, and I were working on it, trying to figure out what can we do to figure out how to improve the color while still getting some of the micro loads. And so we went through, we looked at myoglobin states, what's bound to it. We looked at a lot of different things, and still we're kind of stumbling. And I finally thought one day, what if we look at going back to our basic meat science? We raise the pH a little bit, we get a little bit more stable color, and see how that'll work. And we did a little pilot study. It kind of worked. The problem in ground beef is it had a slight sausage-like texture. No one wants that. But we got talking about it a little bit more, and I finally just decided I need to reach out to my peers elsewhere, and I needed a color chemist, so Dr. Ramanathan is the person I talked to next.
Yep, absolutely. And so when you came in, Dr. Ram, you've been doing a number of color studies, but maybe have you been really focusing more on dark cutting lately, would you say?
Yes. So before starting, first of all, thank you for hosting us.
Yeah.
I'm a big fan of MeatsPad, so
Me
glad to
too.
be here. So we have been working on dark cutting beef for the last 12 years. So two aspects: one, white causes, and other one, how we can improve the appearance and value. So I had a student, Andrea English. So she started with the first study. We did some aging study. Then another student, we tried with the different packaging. So when we package with the high oxygen, so high oxygen means our atmosphere has close to 20% oxygen. So more oxygen, more bright red color. So we tried, what about if you package in 80% oxygen or carbon monoxide? So when you package the dark cutting beef, it don't have that dark color, it looks bright red. Okay. And then we tried enhancement. I know you tried the rosemary enhancement. Likewise, we enhanced with rosemary. So one of the goal with the rosemary enhancement, because when you're adding water, this water can dissolve more oxygen, so that way it will brighten up. Oh, wow. So we tried a combination of enhancement and map packaging. So map means when you go to a store, like you'll see a tray, rigid trays with packaging. So we tried the combination, it worked great. Then one of the challenges with the dark cutting beef, it has a high pH, so the microbial content is greater. So maybe they like mine thing alike. So we thought like the HPP is a great technology. What about if you try in dark cutting beef? Because one, when you have this high pH, the muscle structures are closed. So when you apply some force, such as like high pressure, maybe it can break it down and it can increase the oxygen diffusion. So it was a perfect time because we have the problem and Gary has the tool. Yeah. We talked and it was instantaneous. Like we know what, as Gary mentioned, he was trying with some high pH beef, trying to increase pH with addition of some alkali compound. Here we have a dark cutting, so it worked out well. We tried some testing. Again, we did series of testing. I'm sure Gary can talk more about what is the impact, but no one did it before with the dark cutting beef. Right. So we tried different levels. Gary, you can add what happened when we put high pressure, like 600 megapascal.
Yeah. So when we looked at it, we tried different levels going through it and kind of identified some holding times at that. And one of the challenges as we went higher pressures, especially those that we get to where we'll get pasteurization, it really looked light. But at some of the lower pressures, so we're still talking 43,000 PSI, but when we got down to 300 megapascals, we really had pretty nice color on it. And so one of Ram's students, or several of his students, came up and worked with our students at University of Nebraska, and Dr. Grace Denau, who's in our food processing center and kind of coordinates the HPP facilities. They came up and we ran a series of projects with it and have come out with some of the publications. But when we get to that 300 megapascals, it really lightens the color some. We get a nice reddish color, but we're not getting the cooked color. Yeah. And so it makes that dark cutting steak, which people don't like, has discounts that are associated with it, makes it look like it almost a normal steak.
Yeah. And the advantage, if you have a dark cutting steak, and dark cutting steak we applied with 300 megapascal and a normal pH, it looks like a normal pH beef, bright red, smiling at you. Yeah. And when you cook
the angels are singing and everything, you know? Peace on earth and goodwill toward everyone, right?
Other advantage, in our previous study, when we enhance, we need to put in a rigid tray. Yeah. But this one, you can just PVC overwrap. Yeah. It looks like a normal pH. And also Cole, one of our previous students, he did some cooking and did some taste panel. Oh, no difference. No. So we can improve the value actually. So based on that one, we wrote the NCBA grant to understand more about different cuts. Again, Gary can add more about it. We are using middle meats, isn't it?
Yeah, so primarily focusing on the middle meats with it, because when we look at what value can be added to it, the other meats tend to go to trim and not as much of a discount, but in the middle meats, there's really a major discount with it. So looking at where it looks like it would have the most application is ribs, strips, tenderloins, maybe top sirloins, because you could add the most value back or regain some of that discount that's associated with dark cutting beef.
And also in that project, we are interviewing processors. So we are interviewing 10 different processors to see, hey, how much does a dark cutting beef have? If we have this technology, will you adopt? Or so, we really want to know what are the challenges. So hopefully by end of this study, we'll do some economic analysis and see, okay, for high pressure processing, this much cost. If you improve the value, this much is benefit. So we really want to, I know these are underutilized curd. It's going to the restaurant. Maybe as the prices are high, maybe we can have a different market for our dark cutting beef. So that's our goal.
The mission of the USMEF is to increase the value and profitability of the U.S. beef, pork, and lamb industries by enhancing demand for their products in export markets to a dynamic partnership of all stakeholders. Simply put, USMEF is putting U.S. meat on the world's table.
I've seen the pictures. I am a believer. Anybody who sees these pictures will just be, you will be in awe. It is unbelievable how effective this process is. And you're not adding any ingredients. Zero. You're adding pressure. That's it.
So it's just all the pressure with it. So going forward, we want to look more at optimizing what's going along with it, and as we go through it. And so we want to make sure that we can kind of optimize that process, define what's happening, and then doing more on kind of that consumer and economic impact. Phil, we'll have to make sure we share the link for the paper that's out there, so you can put that on the podcast site.
This is just absolutely incredible.
And also, I would say it's pure science. Like, it's not like randomly we are doing by step process. That's one thing I feel like a lot of people understand, the importance of science and R&D. Once you apply or once you change this little bit of structure, that will help to oxygen to go inside and bloom it.
I mean, this is just a whole new way of thinking about meat structure, meat color. So often we're trying to inject something or add something, and all you're doing is just manipulating the structure a little bit, and bam, you have repaired a major problem. And granted, we've gotten better and better at minimizing dark cutting, but it hasn't gone away. And it's a major loss to a producer or a packer, if they end up with a dark cutting animal.
I mean, USDA reported price discounts are $35 a hundredweight.
It's huge. It's enormous. And with the amount of demand that is out there for beef right now, we can't afford to miss out on any of these carcasses.
Yeah.
So, but we still think it's a starting stage. If we want to scale it up, we need to do more research, like if you do it in a loin versus half carcass. So that way we can really scale it up. So, and also we would like to learn, like even in normal pH, why it is having that pale color. Can we manipulate, I want to use the word manipulate, maybe understand what is the storage stage, maybe the temperature. I'm sure Gary can add more to it and have a normal appearance.
Yeah, so really looking at defining what happens so we can best optimize that system is really what we need. And so when it comes to the HPP processing, the time, the holding time, the pressures we use, the temperature of the water around it will all make an impact on that. One thing, it may be that you could optimize it. Darker products might need more time than one that's kind of a moderately dark, and so you can look and see how that manipulation and really fine tune it going forward, I think.
Yeah, so you're saying that the next steps would be to try to figure out, if you knew the pH of a certain muscle or a group of you could select by, like, you have all these that are maybe 5.8, or you have a whole bunch of them that are 5.9, 6.3. You can calibrate the pressure amounts that you would need.
Yeah, so you might look at pressure and time that it takes to do it, and so also the difference on the cuts. Tenderloins might be different than a strip loin just from that inherent difference in the muscle.
Yeah, yeah, it's different. How about shelf life? Did we fix the shelf life question of dark cutting?
We did color study, so we had the control, normal, dark cutting, control, different level. What we are seeing is at a low pressure, like 300 megapascal, it's looking bright red even after 7 days, because the pH is slightly higher, and it has more shelf life than the normal pH one. So shelf life base, it's good. and also bright red. Yeah.
From a micro standpoint, we do need to look a little bit more at that. Something that we're going to plan on some future studies to see how that impacts it. You know, it may be a product. You know, it's not going to be a choice steak, normal steak, but we can get closer. You know, it could be something you have to HPP and then do frozen, or but there's lots of ways we can do, and we can get a lot closer to that characteristic that you expect in a normal pH steak. Especially compared to where we start at dark cutters.
Well, but you must be reducing the base spoilage microbial load during this process.
Yeah, so it depends what pressure we work at. You know, when we get at 300 megapascal, there may not be a big impact on the pressure. If we get up higher than that, I think 400 and above, we might get more microbial reduction. And so a lot of that micro load is pressure dependent. It's amazing what bacteria can stand up to and survive.
Yeah. No kidding. Well, guys, I mean, I'm flabbergasted. I'm amazed at, you're taking your foundational research and your understanding of how muscles operate, muscle structure, muscle chemistry, and bringing this technology that, how long has it truly been around from a commercial use?
I'd have to look and see how long it's been there. Some of the first applications were like in guacamole, fresh juices. You'll see it in. They'll use it to help shuck seafood, and so there's a lot of applications beyond kind of that safety side that can be used. But there's toll processors around the country, and so it may not even be that someone has to put their own unit in. They can just work with a toll processor
you can
that's out there.
Accumulate and then ship it, and then let them do their thing.
Yeah. And that's another question: is how long can you accumulate? Do you age them first, then HPP, or HPP and then age? Looking at some of those, there's a lot of kind of that application side that needs to be done to really figure out an optimized process.
Based on your just understanding, I know you haven't tested this, or maybe you have. But what would you say happens to the aging enzymes under that pressure?
I think because this is a slight pressure, so what happened during this process, it will damage the mitochondria and also the muscle structure. So the enzymes are liberated at the same time. The pH is greater, so that's why it is not turning brown faster. But if you're doing in a normal pH, if you're applying it, it will turn brown faster. So we have some benefit with the high pH. At the same time, as Gary mentioned, we probably have to look at the microbe. Again, it's not terribly high, but still we want to make sure everything is within the limit and safe.
I mean, it's incredible that you just said we have a benefit from the higher than normal pH here, but in this case, it is a benefit. That's absolutely amazing. How about what about? Does it do anything to like the fat content? And I know the fat's not going to go away, but does it change its shape at all? Do you have any smearing that you have to deal with? Or?
No. So one of the neat things about HPP is because it's in the water, the pressure is uniform from all sides, so you don't disform the product. And so that's where the same way you could apply it to a steak, you should be able to apply it to a whole loin. Some of the research we've done a third or a fifth of a loin, and it works, but it should work in a whole subprimal as well. And so it doesn't deform it. It shouldn't really affect the fat. And so it's...
So one thing it was a great point. I'm sure you heard about rancidity, like rancid fat, rancid oil. So we were a little bit concerned what the rancidity level, but based on our previous research, at a high, like 600 megapascal, it increased the rancidity. But at 300, no problem. So that's why the taste panelists, they didn't notice any abnormal flavor. Actually, the high pH can hold more water. It was more tender. It had more juicy.
It's rare that I can't find words, but I am speechless at the moment.
We had the same feeling. Like when Gary sent me the pictures, wow, we thought, wow.
This is a game changer, guys, for sure.
One of the fun things about it, and I think the industry as a whole and the academia, the interaction and finding solutions to industry problems, we thrive on it. It makes it fun and exciting, and this is just a great example of that.
And I would say it was a great collaboration. Like we love collaboration, but we never have that two people think differently for a common cause. I know Gary was working on high HPP for a very long time.
Yeah.
I was working on the dark cut for a very long time, myoglobin, all the stuff. So
Yeah.
I would say it worked out.
So when I explained it, he said dark cutting. I'm like, duh. This is the perfect example. So
Well, yeah, and you know that it is a perfect example of just getting a different set of eyes looking at it, you know, and using your different expertise and tools that you may have at your resources to solve those problems. So I'm very impressed. I'll tell the listeners out there, for those who aren't able, we will try to post those images that you have. Both of these individuals, I haven't seen any pictures of their family, kids, or anything, but they have shown me pictures of their steaks that they're very proud of these days. And so I really hope that their children also get to know about some of their great accomplishments at some point. But no, guys, I really appreciate this. I'm excited to see what the future holds, and maybe next year we'll have even more understanding, maybe some modeling that goes along with this to help our packers with a very applicable solution to something that's been a bit of a thorn in our side for a very long time.
Thank you, Phil, for hosting us and telling our story. I hope, I'm sure all the listeners will enjoy it. We are trying to help everyone, including producers.
Yeah. This is great.
yeah, thank you for the opportunity.
Of course. Yeah, we'll stay in touch.